Hello guys, and welcome back for today chemistry class. So for today class we're going to cover a new subtopic, which is subtopic 1.4. But before that, let us take a look what you have learned in the previous subtopic, which is subtopic 1.3, voltaic cell. Okay, so the first one you have learned about simple chemical cell. Okay, simple chemical cell. uh, Chemical cell is a cell where chemical reaction take place to produce electrical energy. So the conversion of energy is chemical energy through chemical reaction to produce electrical energy. And for simple chemical cell, okay, pelajar kena tahu dia punya apparatus setup. Senang saja. Okay, the first thing you need to have is two different metals as electrode. So contohnya di sini you guys have magnesium metals and copper metals, where both metal are deep into electrolyte. Okay, electrolyte, and ini kita akan bincangkan in details what is electrolyte, but to simplify what electrolyte is, electrolyte is ionic compound that dissolve in water. Okay, so you have solution of ionic compound. Okay, dan kena ada voltmeter. Okay, voltmeter untuk kira dia punya electrode potential. Okay, selain untuk kita ukur electrode potential, we can use voltmeter to identify the presence of electrical current. Okay, bila ada electrical current, meaning there are flow of electron. Okay, so next, apa yang pelajar kena tahu untuk chemical cell, you need to know how to determine negative terminals and positive terminal of the cell. Okay, to determine the terminals of the chemical cell, you have to look at their E0 value, electrode potential value of the metals. So first, the E node of magnesium is more negative than the E node of copper. Okay, so macam mana cikgu tahu? You have to take a look at the standard electrode potential series. So magnesium is more negative than copper. Okay, cikgu mau pelajar ingat balik, di atas nih more negatif, di bawah ini more positif. So more negative metals will become the negative terminals, ataupun yang kita panggil sebagai anode. Okay, anode. And then we have the positive terminals of the chemical cell, which is copper. Why copper? This is because copper is more positive, okay, located below magnesium in electrode potential series. Okay, copper is more positive, so copper become positive terminals. So that's all for simple chemical cell. And then for chemical cell, we have voltaic cell. Okay, we have voltaic cell, also known as Daniell cell. Okay, so what is voltaic cell? Voltaic cell is a combination between two half cell. Okay, so meaning here we have half cell of zinc, and then on the right side we have the half cell of copper. Okay, so for voltaic cell or Daniell cell, we have two type of them. The first one, we have Daniell cell that use salt bridge, and then the second one, we have Daniell cell that use porous pot. Okay. Untuk Daniell cell, pelajar kena tahu setiap half cell itu ada dua half cell yang kita gabungkan. Setiap half cell itu elektrod dia mesti sama dengan dia punya solution. Maksud cikgu, zinc electrode mesti direndam dalam electrolyte yang ada zinc ion. Oke, contohnya zinc sulfate, oke, zinc chloride, zinc nitrate. So same goes with the other half cell. Let's say copper, this must be dipped into solution electrolyte that contain copper 2 ions. Okay, copper 2 sulfate also can, copper 2 chloride also can. Same goes with the Daniell cell that use porous pot. Okay, zinc electrode is dipped into a solution that contains zinc ion. Okay, copper 2 ion. Right. Okay, so that is for Daniell cell. Okay, next you need to know how to write cell notation. Okay, based on voltaic cell. You need to know how to write their cell notation. So for half cell that use metal electrode, cikgu rasa tiada masalah, because this one is quite easy. Okay, cell notation. First you have to write electrode garis macam tu, lepas tu tulis dia punya ion in aqueous state, lepas tu ada dua garis macam ni menunjukkan ada salt bridge dan juga porous pot. Okay, this one kau tulis not solid, dia ada half cell punya solution ion, and then dia punya electrode. Okay, but for this side, this one must be the negative terminal anode, and then the other side will be your positive terminal cathode. Okay, so macam mana kita tentukan? Kita ambil contoh ni lah. Macam mana kita tentukan siapa anode, siapa cathode? Sudah kita cover tadi. So for anode, we have to take a look at the electric potential value. So the E node, the electric potential of zinc is more negative than copper. So this zinc become negative terminal. So just put zinc electrode here and salt that contain zinc 2 ion, and then the other side will be copper 2 ion, and then copper electrode. Okay, so that is for half cell that use metal electrode. But take a look another example that confuse all the student. Question number 1B, because A no problem, but B the half cell, both half cell are in aqueous state. There is no presence of a metal electrode. So how to write them is easy. Okay, so this one, don't forget to put double line there. Okay, porous pot or soft bridge. So this side is anode, right? Anode, negative terminal, and this side is positive terminal, cathode. So for half cell that is there is no metal electrode, we just put platinum, there, and then platinum on the cathode. Okay, so this one is your things that undergoes reduction and oxidation di dalam sini. Okay, so just put PT, platinum, as electrode. Okay, question number 2, calculate the voltage for the following cells. Ini pun banyak yang tidak faham sebab because they are PT here, platinum. What is the function? How? Okay, right. So calculate the voltage. Inert cell, easy formula. Inert of cathode minus with inert of anode. Okay, so we take a look. One question example here, question number C, question C. Okay, the half cell of the anode, here is anode. Electrode that we use is PT because iron is not exist as a metal atom, it is exists as metal ion. Okay, aqueous state, sorry, but here will be your cathode. Okay, good, we use silver electrode. So easy. So how to calculate? First you have to look at the value, inert value of the iron. Okay, kalau pelajar perasan, dalam series ini ada dua iron, here, and also we have another one here. So which value you going to choose? You have to look at the substance. Here we have Fe, iron, Fe2 positive, we have Fe3 positive. So this one, not this one. We are going to use this one when the electrode is iron, but since the electrode is platinum, we're going to choose this one. So we're going to take this value, the inert, okay, minus plus 0.77, is it 0.77, and then we have the other half cell that use silver. So the inert of the silver is silver is over here, just below the other half cell inert. Okay, so we have plus 0.80. So just use simple mathematical solution to solve this problem. So you have value 0.03, must have unit volt, okay, alright. So that is 15 minutes on what you have learned from previous class. not short, not quite short throwback, quite long throwback, but never mind. Okay, because you need all the understanding that you have understood from previous class, so that you will be able to understand the new subtopic, which is electrolytic cell. Electrolytic cell. Previous you have learned about voltaic cell, so you need going to cover new cell again, cell, right? So in this subtopic, what you need what you need to understand, apa yang sepatutnya pelajar dapat. So the first one, okay, you can describe electrolysis. The word electrolysis is not alien for you, because during your lower form you have been introduced with the terms electrolysis, and also the what is actually electrolysis is all about lah, right? So second, describe electrolysis of molten compound through activities. We're going to conduct experiment. Okay, for this one, hope we can do experiment. Okay, next, explain factors that affect electrolysis of aqueous solution through experiment. Okay, next, compare voltaic cell and electrolytic cell. Okay, what is the difference? What is the similarities between these two cells? Okay, and then the last one, describe electroplating and purification of metal by electrolysis through activities. The last objective is the application of electrolysis in industry. Okay, so before we moving on with all the hard content, complicated content, we're going to take a look at electrolyte in details. Electrolyte and non-electrolyte. Okay, the person here named Michael Faraday. Okay, he is English scientist, presented the Faraday law. He named the chemical substance that can conduct electricity as electrolytes. Okay, substance that conduct electricity, electrolytes. And the other substance that cannot conduct electricity as non-electrolytes. Okay, so this is the full definition of electrolyte. Electrolytes are substance that can conduct electricity either in molten state or aqueous solution and undergoes chemical changes. The keyword for this explanation, substance, bahan kimia, can conduct electricity, yang boleh mengalirkan arus elektrik, sama ada in molten tu senang sejak lah. So bahan itu dipanaskan, so dia akan tukar dari solid kepada liquid. That is a molten melting process. Undergoes melting process, you have molten substances. Or aqueous solution. Okay, aqueous solution is a homogeneous mixture between solid and solvent. Okay, solid adalah bahan yang larut dalam dia punya solvent. For electrolytes, okay, bahan yang larut itu adalah salt. Solvent dia larut dalam air. Salt, this is ionic compound lah. Ionic compound. So try to remember back what you have learned from your previous lesson during your form 4 about ionic compound. Ionic compound, most ionic compound can conduct electricity in molten and aqueous state. Dia ulang balik saja. Tapi di sini untuk tajuk yang baru nih dia stresskan electrolytes. Okay. While non-electrolytes are substance that cannot conduct electricity in all states. Okay, either it is in molten, either it exists as solution, still cannot conduct electricity. Okay, so this is the idea of electrolysis lah. Electrolysis. Okay, just the idea of electrolysis. The word electro means electrical energy. Lysis is breakdown, electro breakdown. Okay, actually lysis is chemical process to break down chemicals by using electrical energy. That's why we need to have power supply here. Okay, so bila kita switch on the current will reach into this part, so akan ada tindak balas kimia. So still untuk electrolytic cell, untuk ini kita panggil electrolytic cell. Okay, untuk electrolytic cell tadi ada battery, lepas tu ada electrode. Electrode ni it can be carbon electrode ataupun electrode from other metals. Okay, dan di sini kita ada electrolyte. Electrode itu mesti direndam dalam electrolyte. Okay, coba kamu ingat balik apa yang kamu belajar sebelum ni pasal electrolysis. Okay, I believe you have learned a few things about electrolysis. Electrolysis of water. Kamu buat electrolysis of water. Water is H2O. So when it is undergoes electrolysis, kamu akan dapat oxygen gas and hydrogen gas. So meaning we break down the molecules, lysis it, so that you can have two constituent elements asal. Okay, break down using electrical energy. So kita tengok balik electrolyte. Okay, substance that is electrolytes. Okay, substance that is electrolyte, it can be substance that ionic compound, or it is acid and alkali. Right, so solid ionic compound in solid state cannot conduct electricity. This is because ion in the ionic is in lattice structure, cannot move freely. Okay, so for ionic compound that exists as a molten or aqueous solution, it can conduct electricity. Can conduct electricity meaning it is electrolyte. So if it is in solid, it is not electrolyte. Okay, why it can conduct electricity in molten or aqueous state? This is because the presence of free moving ion. Okay, we need free moving ion here, positive ion, negative ion, okay, so that we can transfer electron from this side to the other side of the electrode, so that we have flow of electron here. The flow of electron meaning the electrical conductivity. Okay, so acid and alkali also can act as electrolyte. Okay, but in absence of water, tiada air, this cannot conduct electricity because there are no free moving ion. So acid and alkali are electrolyte when there is water present. Okay, because acid and alkali will ionize in water, okay, to produce hydrogen ion for acid and hydroxide ion for alkali. Therefore we have free moving ions, so that it is can conduct electricity. Okay, and then we have non-electrolytes. Non-electrolytes are covalent compound. They cannot conduct electricity because they exist as molecules are neutral molecule cannot conduct electricity. Okay, to be specific, they are no free moving ion. So in absence of water, acid and alkali cannot conduct electricity. Covalent compound also cannot conduct electricity. Coba kita tengok persamaan untuk non-electrolyte. Ion cannot move freely. No free moving ion. So meaning that for electrolytes, for substance to be able to conduct electricity or to be classified as electrolyte, it must have free moving ion. I repeat, it must have free moving ion. Okay, so take a look here. We have sugar solution and salt solution. For sugar solution, okay, the light bulb does not light up, but for salt solution we have the light bulb is light up, because in salt solution when we add sodium chloride, okay, salt example sodium chloride, when we add sodium chloride in water, we will have a sodium ion, free moving of sodium ion. What else? We have a free moving of chloride ion. We have free moving of hydroxide ion. This one is from water, and also free moving of hydrogen ion. So we have all these ion moving freely inside the solution, that the things they able to transfer electron, so that we have electron flow. So when the electron pass through the bulb as electrical current, the light bulb will light up. But for sugar solution, glucose is molecule, to be specific, covalent compound. Even though sugar is able to mix with water to form sugar solution, but still the sugar exists as molecule is neutral. There is no free moving ion in the solution. So when there is no free moving ion, the light bulb will not light up. So sugar solution is non-electrolyte. Okay. Comparison between conductor and electrolyte. Table 1.8 shows the difference between conductor and electrolyte. Okay, just now we have covered about you have learned about electrolyte, so let us compare with conductor. Okay, between conductor ni contoh dia electrical conductor biasanya metal kan. Coba ingat balik apa yang kamu belajar waktu tingkatan 4, chemical bonding under metallic bond. Okay, why metal can conduct electricity? This is because metal have metallic bonding. Okay, so for conductor, substance that conduct electricity in solid or molten state only, but not undergo chemical changes. But for electrolyte, okay, conduct electricity in molten or aqueous solution and undergo chemical changes. For conductor, okay, so for conductor, next, substance that conduct electricity without undergoing decomposition. Okay, for electrolyte, substance that conduct electricity and undergo decomposition into their constituent element. Okay, undergo decomposition into their constituent element, maksud dia bahan itu decompose itu dia akan mengurai. So let's say electrolysis of water. So electrolysis of water, water will break into its constituent element. Original dia hydrogen dan oxygen. Okay, next, electrical conductivity decrease as temperature. Can conduct electricity due to the presence of electron that move freely in solid state of metal. Atoms are arranged closely like this. Okay, but they have free moving electron. Elektron ini datangnya dari valence electron dalam metal atom, and these electron are very happy to jump around atom from one atom to other atom. Okay, so that's why metal atom can conduct electricity. Okay, but for electrolyte, it conduct electricity due to the presence of ion that moving freely. Okay, this salt solution can conduct electricity because ions, positive and negative ion, are moved freely alongside the solution. Okay, next, electrical conductivity decreases as temperature decrease. Okay, electrolyte electrical conductivity increase as temperature increase. Okay, next, example of conductor are metals and graphite. Graphite is carbon graphite. And then we have electrolyte of ionic. Electrolyte example, ionic compounds, acid and alkalis. Okay, so that's all for today class. So I hope that you able to understand a little about electrolyte and non-electrolyte, so that we can proceed with the next content, which is more to electrolysis on this chapter. So that's all for today. Thank you very much for listening. Have a nice day. See you again for the next class. Thank you. Bye bye.